Assalamualaikum class, my name is Shiza. Today the topic of my presentation is symmetric elements. Symmetric elements: a line, a plane or a point. Symmetric elements can be further divided into two symmetric operations: transitional symmetric operations and point symmetry operations. Now we will further explain point symmetry operations, which is identity elements, proper rotation, reflection operation, inversion operation and improper rotation. What is identity? It has nothing to do with the symmetry and its symbol is E. Proper rotation is about an axis through some angle. Reflection operation: exchange of points through a plane to an opposite and equidistant point. Inversion operation: inversion is a reflection about a point. Improper rotation about an axis through some angle followed by a reflection in a plane. How to find symmetry elements? We have studied how to find symmetry elements in different molecules. So there is a problem, which is in this question you have to state the single symmetry operation of XCF4 which has the same effect as applying a given operation several times. The diagram below shows the location of the symmetry elements concerned. The diagram is given. What operation has the same effect as A S4 twice, B S4 thrice, C S4 4, D C4 twice and so on. Solutions: A S4 twice is equal to C2. S is a symbol of improper rotation. B S4 thrice is equal to S4 thrice. C S4 4 is equal to E is identity. D C4 twice is equal to C2. E C4 thrice is equal to C4 thrice, which is as same as B. F C4 4 is equal to E. G is sigma twice is equal to E. H is I twice, which is equal to E. Sigma twice and I twice. If we apply improper rotation and reflection operation twice, then this will be equal to identity, which is represented by E. So there is another example to explain the symmetry elements in molecules. So there is a molecule methane. So let's find out complete set of symmetry elements in methane. There are some symmetry operations given. E, which is identity, 8C3, which is proper rotation, C3 twice, C32, 6S4, which is improper rotation, 6 sigma D, which is reflection operation. This is the 3D dimension diagram of methane, and as you can see that there are 4 equivalent C3 axes. The yellow line shows the axis of rotation here. The axis of rotation. There are 4 axis of rotation. Now we will see the C2 rotation. There are 3 equivalent C2 axes, and the yellow line here shows the axis of rotation. Now moving towards sigma d, there are 6 equivalent sigma d planes. You can see in this 3D diagram. So far we have discussed the example of methane, and now we will be discussing the example of staggered ethane. Find out complete set of symmetry elements in staggered ethane. There are 2 types of ethane, staggered ethane and eclipsed ethane. So systematic diagram of staggered ethane is represented here, and we will be discussing this in detail. Identity is present in molecules. There is a C3 rotation in staggered ethane. The axis of rotation is the straight line which is passing by 2 carbon atoms. This is the axis of rotation. Now by applying C3 rotation, we can see that the HA is replaced by HB, HE is replaced by HF, and HB is replaced by HC. Now by applying second C3 operation, the positions of the atoms are changed, but the structure is indistinguishable as the first C3 operation. In both the operations, the structure is indistinguishable, but the position of atoms has been changed. So far we can say staggered ethane has 3 operations. First is identity, second is C3, and third is C3 twice. There are 3 C2 axes of rotation found in ethane: C2, C2 dash, C2 double dash. I will explain the effect of C2, C2 dash and C2 double dash on operation of ethane. There are 2 patterns. One is solid one and the other one is dotted one. Solid is towards observer and dotted one is away from the observer. HD, HE and HF is on the backward side. HF take the position of HA, HE takes the position of HB, and HD takes the position of HC when the operation C2 is applied. When operation C2 dash is applied, the backward atoms will change their position and appear as upward atoms. When operation C2 double dash is applied, its results are the same as C2 dash, but the position of atoms have changed. So far we have studied E, C3, C32, C2, C21 and C2 double dash. There are 3 types of sigma D: sigma D dash, sigma D double dash. When sigma D operation is applied, the atoms which is in the axis of rotation of sigma D, which are HF and HA, will remain unchanged, and the atoms which are on their sides will interchange with each other. In sigma D dash, the atoms which are present on the axis of rotation will not change their positions, which is HD and HB. and in sigma d double dash, the elements which are present, the atoms which are present on the axis of rotation will not change their position, but the atoms which are present on their sides will interchange their positions. So this possess sigma d operations of three types. So far we have added three reflections: sigma d dash, sigma d double dash. Note that there is no sigma h for staggered ethane. Inversion center, whether it contains or not. We take central point in the molecule and then we check by traveling on both sides opposite to the center. If they have same atoms on opposite sides, then there will be a inversion center, and there will be a inversion operation as well. Ethane also have inversion center, because when we move from the center HA, and when we move on the other opposite side HF, both have the same atom. And when the inversion of the molecule takes place, the position of the atoms are changed, but they do possess inversion. Improper rotation. Finally, staggered ethane also has an improper rotation axis. It is a S6 S2N axis that is coincident with the C3 axis. Rotation followed by reflection is known as improper rotation. S6 means we need to apply C6 first. C6 means 360 over 60. We need to rotate the molecule 60 degree anti-clockwise. After C6 we need to apply sigma h. Molecule on upper side will go on lower, and on the lower side the molecule will go on upper side from the lower side. C6 into C6 is equal to SE twice and is equal to C3. So we don't need to write C6 because C3 is a major symmetric element. In this we can see that by C3 rotation, which means 60 degree rotation, the HA will be replaced by HE, HB will be replaced by HE will be replaced by HB, HB will be replaced by HF, and so on. It turns out that there are several redundancies when counting up the unique improper rotations. So S6 is equal to S6, S6 twice is equal to C3, which is major symmetry, and S63 is equal to I, which is major symmetry. SC4 is equal to C3 twice, which is major symmetry, and S66 is equal to identity, which is major symmetry. So the improper rotations add only two unique operations. This is a 3D diagram of staggered methane, and the C2 operation and C3 operation is shown here. The yellow lines are the axis of rotation of C2 and the red line is the axis of rotation of C3. You can see In staggered ethane, as we know, there are two line patterns, dotted and solid. Here we can see the dotted and solid in a clear vision. Show odd planes. You can see their planes as well in the diagram. This is the last example of the topic. Find out complete set of symmetry elements in SF6. We have three views here of SF6 molecule, and we can see the symmetry operations which are given here. E identity 8C3 6C2 6C4 3 C2 inversion 6S4 and 8S6 3 sigma H and 6 sigma D is equal to 48. So there are a total of 48 symmetry elements in SF6 molecule. This is the last example of this topic, which is SF6. It has octahedral geometry and C4 rotation is being shown. And this SF6 has 48 symmetry elements. You can see C3 axis rotation. The lines, yellow lines, represents the axis of rotation. There are C2 axis of rotation, so many C2 axis of rotation. There are 6 C2 axes of rotation. There are 9 planes of symmetry operations present in SF6 molecule, as you can see in this 3D diagram, showing all symmetry elements. Thank you for watching my presentation. I hope you will like it.